I'll come in there in a little. Come in there in a little while. I'm already on here. I will come in a little while. I will come in a little while. I'm already on here. Why are you so mean today? Did y'all see Dr. Hertz thing that Morgan just sent in the group chat?
Yeah, it was
Who was that?
it was one of Matt's friends, Matt and Johnny Ray's friends. They gave him the log on, and he started playing like gospel music in the background.
Oh my god.
It was funny. That's what I was reading.
That's so sad.
She's so mad.
That's so sad.
She's pissed about it.
She said, I think I have treated you all with respect. I tried to anyway. That's so sad.
That is really funny though.
Oh my god. So I honestly don't even know why I'm in this. I haven't taken any of the quizzes. So like
I had already taken the one for last week. And so I just left the Zoom because I was like, I'm not going to have to listen to the whole message when I'm going to.
I just want to talk to Miss McClure.
Me too. I just want to talk to everybody.
Miss McClure knows everything.
She has
So they like, my mom is still an essential employee, so she has to come in, but they shut down her office to the public. So like she had to come outside and like escort me in today and unlock all these doors and all these like the stairwell was taped off. You had to use the elevator and they had like plastic over the buttons and it was crazy.
Oh my gosh. Miss McClure.
Hey girl.
Hi.
Where'd she go?
She not listening to us? She's on mute. You're on mute.
Hey.
My friend came and stood in my driveway today and like stood 6 feet apart from me and we talked for like 30 minutes. I felt very weird standing in my driveway talking.
Everything is weird. Like, I don't know. I feel like I'm breaking the law when I go outside.
Yeah, I know. Well, I wasn't really following like the rules before, but now my mom is making me follow the rules.
I was following. I was like if I went anywhere, it was like me and one person. Like I went to like Matthew's house.
I mean,
That
I
was
was
really,
always like under the 10 people, but it was like,
yeah, I was too. Or like I went to the lake.
yeah, and that's not against the rules.
Touch. Hey, Miss McClure.
Hey, can you hear me now?
Yes.
Yes.
Okay, I think I gotta go out and come back in. Mine's acting cray-cray. Hold on.
Okay.
My family's doing like fake chopped tonight, so I have to cook dinner with my fake basket ingredients.
Matthew's family did that the other night. I was a judge.
My mom is trying to come up with fun things to do while we're on quarantine, so that's what we're doing.
Have you seen on TikTok when people do like themed dinner nights?
Uh-huh.
That looks so
What's his name?
fun.
What's his name? It's really funny. Derek. That's his name. Do you see the thing on like online where Zoom had gotten like security breaches and stuff and they could turn on people's cameras without them knowing?
Ooh, that's creepy.
I know, it kind of freaked me out.
Why can't I copy the link and send it to Callie?
Because she has to get into it herself. It's like in Canvas on the side.
Tell her to go to Canvas, click on Zoom.
I'll send
If you tell her to go to Canvas and then click on Zoom, she'll see our meetings in there and then she can join from there. Thank you for your help.
You can just do it when you get home later. I'm in class right now. Bye.
And I'm gonna see if I can mute all of you.
Do you want me to mute myself?
You can. I was just playing around, seeing if I could do it too. Okay.
I think you can because my teacher kept muting people.
I think I just tried to mute all of you, but you are allowed to unmute yourself if you need to talk or you have a question, okay?
Okay. Thank
All
you
right,
for
so last Thursday, we started with vectors and we were doing adding, subtracting, we were finding unit vectors. We found the magnitude of the vector, which was where you're looking at the length of the vector. So today we're going to continue our study with vectors, and you see here that it's called 6.4 vectors and dot products. Dot products is when you are multiplying two vectors. So you will be multiplying the vector u times vector v. You can see here our formula for multiplying the two vectors. You just take this first point, the second point, multiply them together. The second point here, second point here, multiply them together, and then add your two answers. The next thing we're going to look at today is angles, finding an angle between two vectors. And if theta is the angle between two non-zero vectors u and v, then the cosine of theta equals, notice here in the top in this formula, u times v, that represents the dot product. So you will be multiplying these two vectors in the top. And in the denominator, the two absolute value bars beside each other, that's the magnitude of u times the magnitude of v. So you'll be looking at the length of u times the length of v. And then the third thing we're going to look at today is the definition of orthogonal perpendicular vectors. The vectors u and v are orthogonal if the dot product of the two vectors equals 0. If it does not equal 0, but the vectors are ratios of one another, then those vectors are parallel. Sometimes they're neither. Actually, most of the time it's neither. But if it's perpendicular or parallel, then you'll have one of those two scenarios. The examples we're going to look at today are out of your textbook on page 437. I'm going to start with numbers 8 and 10. So if I'm finding the dot product of u times v, and my first vector is 6, 10, and my second vector is -2, 3.
Is that supposed to be another one of the like triangle things? Or is it supposed
Yes.
to be parentheses?
Yeah, this. Yes.
Yeah.
I'm sorry. Oh, it's a bad habit to write a parenthesis, and 9 times out of 10 I do that, and I don't mean to. So thank you, Lauren. All right, so we're going to do u times v. So that is going to be 6 times -2 plus 10 times 3. So 6 times -2 would be -12. 10 times 3 would be 30. -12 plus 30 would be 18. Okay, the dot product of number 10. It's going to be -2 times -1 plus 5 times -8. So -2 times -1, +2, plus -40, which equals -38. All right, the next two examples we're going to look at, numbers 12 and 14, are two vectors. We're looking for the dot product, but if you notice, these vectors are written in linear combination form. So if you want to change back to component form, then this u vector is 3, 4. And this is 7, -2. Remember that it's just the coefficients in front of your I and your j. If you're going to do your dot product of u times v, then it's going to be 3 times 7 plus 4 times -2. So 3 times 7 is 21. 4 times -2 would be -8. And 21 plus -8, or 21 minus 8, is 13. Number 14, your coefficients here are 1 and -2, -2 and +1. So if I'm multiplying u times v, it's 1 times -2 plus -2 times +1. So that's -2 minus 2, which is -4. Any questions so far? All right, we're going to look at some more multiplication here. Let me give you a second to write this down. We're going to be using these three vectors. The u vector is 3, 3. The vector is -4, 2. And the w vector is 3, -1.
Which formula is that for?
I'm sorry. So we're going to be using these three vectors for the next couple of problems, next couple of examples that we're going to do.
So like on a test, you would be given that and you'd have to plug it into these formulas.
Yes. Well, not really a formula. So we're going to be evaluating these vectors. So you're going to plug the U vector in here times the V vector. So let's look at what we have going on here. First of all, we have scalar multiplication. We're going to have to multiply 3 into each of these vectors. So 3 times 3 is 9, and then 9 again. And then you're multiplying these two vectors. So this is where you'll be doing a dot product. So 9 times -4 plus 9 times 2. So 9 times -4 would be -36. 9 times 2 is 18. And then -36 plus 18 would be -18. Sometimes you will get a number answer. So that they call this a scalar answer. But sometimes you may get an answer that is actually a vector. So in number 18, remember, please excuse my dear Aunt Sally, we have to do what's inside the parentheses first. So we're going to do the vector V times vector U. And I'm going to do that first and then worry about the W. So this is dot product inside of these parentheses. So that's -4 times 3 plus 2 times 3. So -4 times 3 will be -12. 2 times 3 is 6. 12 plus 6 would be -6. And then I'm going to plug in for my W vector. Now you'll want to distribute. So -6 times 3 is -18. -6 times -1 would be a +6. So you can see here we got an actual vector answer. Any questions? All right, let's look at number 20. That would be U times 2V times W. So every time, follow, please excuse my dear Aunt Sally, start with your parentheses first. We're still using these 3 vectors that I gave you up here in the top. So my U vector is 3, 3. 2 times my V vector, and then my W vector. So I'm going to distribute inside the parentheses. So 2 times -4 is -8. 2 times 2 is 4. So you're multiplying 2 vectors together, so that's your dot product. So it's going to be 3 times -8 plus 3 times 4. So 3 times -8, -24 plus 12. So -24 plus 12, you have -12, and then plug in your W vector, which we know our W vector is 3, -1. And then it's just scalar multiplication. So -12 times 3 is -36, +12. And again, you have a vector answer. All right, this is the problem for number 22. What do you think that's asking for? What's that symbol right there around the U?
Absolute value.
I'm sorry, Callie, what'd you say?
Probably the wrong answer.
I didn't hear you, honey.
I said absolute value, but I don't know if that's right.
No, but that's a good guess. Those are absolute value bars, but it's 2 absolute value bars on each side. So think back to last Thursday. We found the magnitude. The 2 absolute value bars on each side of the vector, that's a symbol for magnitude. So remember that magnitude is the length of a vector, and the formula for that, remember your U vector, 3, 3. So if that's your component form, finding the magnitude of your vector is just first number squared plus your second number squared. So 9 plus 9 would be 18, and then break down your square root. So 9 times 2, square root of 9 is 3, and then 2 underneath. This is just a number, this is not a vector, so that would be a scalar answer. Everybody okay? I'm gonna move on. All right, here's a challenging one. We're still using those same vectors. V times U minus W times V. So you're doing the dot product twice. The V vector is -4, 2. Times the U vector, 3, 3. The W vector, 3, -1. Times the V vector, -4, 2. So you have -4 times 3, 2 times 3, 3 times -4, -1 times 2. I don't know if that should be a parenthesis or a vector. -4 times 3 would be -12. 2 times 3 is 6. 3 times -4 would be -12. -1 times 2 would be -2. So that's -6 minus a -14. I think you all can agree that's 8. All right, next we're going to find the magnitude of a vector using a dot product. This vector is 4, -6, and we want to find the magnitude of this vector. Then you're going to actually take the vector and square it. So that's going to be 4, -6 times 4, -6. So 4 times 4 plus -6 times -6. 16 plus 36, which is going to be 50. We need to take the square root of this. $52 is what? 2 times 26? 4 times. 4 times 13 would. Somebody with a calculator. Can you do 4 times 13? Make sure I'm right. So the square root of 4 would be 2, and square root of 13. And if you want to be less confusion, just go ahead and put your square root under. the whole
It's 2 to the square root of 13. You're right.
Awesome. Thank you.
I was talking back to you, and then I realized that you couldn't hear me. So
I want to do one more of these. They may give it to you in linear combination form. So let's see, you have 12i minus 16j. And we want to find the magnitude of this vector. So remember, component form would be 12 negative 16. It's just your coefficients in front of your linear combination. So we would do the square root of our dot product. So 12 times 12, 144. Negative and a negative are going to make a positive. 16 times 16 would be 256. $256 plus 144 would be 400. And the square root of 400 is 20. Sorry. Now the next thing on our notes was finding the angle between two vectors. And you'll see your, I think I just rewrote 28, so we'll skip ahead. All right, so we're looking at the finding the angle between two vectors. I gave you a formula for this in the beginning of our notes. And the formula for finding an angle between two vectors is the cosine of theta equals your dot product divided by the magnitude of each vector. So let's fill this out. We have the cosine of theta equals, we're going to do dot product of u times v. So that's going to be 3 times 4 plus 2 times 0. And then we need to do the magnitude of u, which is 3 squared plus 2 squared, times the magnitude of v, which is 4 squared plus 0 squared. So in the top here, 3 times 4, 12, plus 0 would be 12. In the denominator, you have 9 plus 4, which is going to be the square root of 13, times 4 squared is 16, plus 0, so the square root of 16 would be 4. And then I think we can agree that 12 divided by 4 would be 3. And now we need to find theta. Make sure that your calculator is in degree mode. I'm going to pull up the calculator. Can you see the calculator? Hey, Lauren, can you thumbs up if you can see the calculator? Oh, let's see here. Okay, better? Yeah, you're on it. So first thing we're going to do is check, make sure the calculator's in degree mode, which this one is not. And then you're going to use your inverse cosine. So the blue cosine. And then I'm going to do my alpha y equals for my fraction. And you could put 12 over the square root of 13 times the square root of 16, or if you've already reduced it, choose 3 over the square root of 13. And then that gives you your angle measure. So 33.69 is going to be the measure of your degree between those two vectors. All right, the next example is number 34. These two vectors are written in linear combination form. So I would just simply rewrite those into component form using your coefficients. And then you just follow your formula. So if you're looking for the angle between these two vectors, the cosine of theta equals the dot product of each of these two vectors divided by the magnitude of each vector. So we have 2 times 1 plus -3 times -2. 4 plus 9 would be 13. And then 1 plus 4 would be 5. So 2 plus 6 is 8. And you can go ahead and put that part in your calculator. We have 8 over the square root 13. Make sure you get out of there and then do square root of 5. If you don't close your parentheses, it works out fine. So our answer here is 7.13 if you round to 2 decimals. Does that make sense? All right, if y'all are okay, I'm going to skip to number 40. I'll give you a second to write these down. All right, so we're still looking for the angle between two vectors with these 2 points here. If we go to our unit circle, and you don't really need to pull it out, just think about pi over 4. What would be your ordered pair at pi over 4? I think you all remember that's the easy one. That's the square root of 2 over 2. So I'm going to rewrite this instead of the cosine of pi over 4. I'm going to rewrite the cosine of pi over 4 is the square root of 2 over 2. I'm going to replace that with square root of 2 over 2, and then the same thing for my sine. And then over here, at pi over 2, that's a 90-degree angle. So that's ordered pair is going to be 0, 1. So that would be 0i plus 1j. And you all know that you don't need a 0i because that wouldn't exist. And you don't need a 1 in front of the j. So component form of this would be square root over 2. And over here it would be 0 and 1. So I have the cosine of theta equals, I'm going to do the dot product. I messed up. over my magnitude. So I have 0 plus square root of 2 over 2 times 1 is just going to be square root of 2 over 2. The square root of 2 squared is going to be 2 fourths, and then plus 2 fourths would be 4 fourths, which is 1. Square root of 1 is 1. I'm going to say that one more time. So we have the square root of 2, and if we square that, that would come out as 2. And then 2 squared is 4, and then the same thing. So if you do 2 fourths plus 2 fourths, that's going to be 4 fourths, and the square root of 1 is 1. And then over here, 0 plus 1 is 1, and the square root of 1 is 1. So 1 times 1 would end up being 1. So now you're at this cosine of theta equals the square root of 2 over 2. So where does the cosine of theta equal the square root of 2 over 2? I think we can answer that without our calculator. You put it in your calculator, you would get 45 degrees. Now, the last thing we have to talk about today is our finding whether our vectors are perpendicular or are they parallel. So in the beginning, we talked about if two vectors are perpendicular, the dot products of the two vectors equals 0. And if they're parallel, then the vectors are ratios of each other. So these examples are in the textbook, starting with number 54. We're determining orthogonal vectors, which again just means is it parallel or is it perpendicular? So our first question is the dot product equals to 0? So we can try that. 3 times -1 plus 15 times 5. 3 times -1 would be -3. 15 times 5 is 75, and I think we can all agree, no, this is not 0. So what that means is that it's not perpendicular. So then you want to know, are these parallel? They're parallel, then they are ratios of each other. So you will do 3 times -1, 15 not sure how I did in my notes. Let me look at this for a second. So I just did -1 times 3 equals -3. 15 times 5 equals 72. And are these the same? No, so they're not parallel. So they're neither. All right, number 56, the component form would be 1, 0. And negative 2, 2. So first we're going to check dot product. 1 times negative 2 plus 0 times 2, which would be negative 2 plus 0, negative 2. And since this is not 0, it is not orthogonal, which is also known as perpendicular. Then we're going to check our ratios to see if they are parallel. So 1 times negative 2, 0 times 2. And I think we can agree they're almost equal, but they're not. So they're also not parallel. The last one that we have is the cosine of theta and sine of theta. And then the v vector is the sine of theta and negative cosine theta. So we're going to do dot product. Cosine of theta times the sine of theta plus the sine of theta times negative cosine theta. Now, you have cosine times sine minus, if we switch to order, because community property says we can change order, right? That'll be minus cosine times sine. What's cosine sine minus cosine sine? That would be 0. Since the dot product is 0, then these are orthogonal. Don't let this confuse you. This right here is just like combining like terms. Now, if you want to practice some problems at home, you can practice page 437, numbers 7 through 39 odd, and 53 through 57 odd. You do not have to do these problems, but all the answers to these are in the back of the textbook. So you could check your answers and practice that way. And if you get stuck on a problem, you're not sure how they got that answer, shoot me an email and I'm happy to help you. The quiz for this lesson is posted. Of course, it's not due till April 27th. I put all assignments due April 27th. But go ahead and start working on this. And if you have any questions, you can either wait till Thursday when we Zoom, or you can email me at any time, and I'm here to help you. So please shoot me an email if you need help. Go ahead.
I was taking that quiz, and I got the same answer